This is the video that goes along with our guided notes for mixture word problems. Okay, so anytime we're talking about word problems, we're going to talk about a strategy or a formula that you're going to use. This time is going to be more of a strategy instead of a formula. Okay, so what we're going to do is we're going to use a little spreadsheet to help us organize our information. Now let's think for just a second about what mixture problems are. Mixture problems are problems that deal with mixing something that is a stronger concentration with something that is a weaker concentration to get something somewhere in the middle. Now, sometimes if you think about maybe like tea or coffee, sometimes just really bitter lemonade, we'll get it and it's just not the right strength, it's not the right flavor, we just can't drink it or consume it, so then we'll start watering it down. Okay, so that could be a mixture problem. It could be mixing something like trail mix. Okay, when you eat trail mix, do you like more goldfish in yours or do you like more M&Ms? How is it mixed up to get it just the perfect the way you want it? Okay, so you're taking something much stronger concentration, mixing it with something less strength and concentration, and you're mixing it and you're trying to find something somewhere in between the two. And even if you're in art class and you're thinking about paint, you want a certain shade of red. Well, you know, if you want a certain shade of red, you're going to take a red and you're either going to add white to make it lighter shades, or you're going to add maybe say black to make it a little bit darker shade. How do you mix that up to get exactly what you want? Okay, again, that's a mixture problem. Now we're going to work three together. Okay, but let's back up for just a minute, because I said there's a little table that we're going to use to organize our information that will help us set up our equation. So what I'm going to do is I'm going to make a table right here with 3 rows and 3 columns. Okay, so I'm making a 3 by 3 table. Now, here's what we're going to do for headers. Above this first column, our header is going to be amount. There's a little multiply sign right there, like right between the 2 columns. This column is going to be percentage. Right here between these 2 columns, we're going to have an equal sign. And here I'm going to write total amount. Okay? Now, our row headers. This first row is going to be mix number 1. Okay? The second row's title is going to be mix number 2. Okay? Now I'm going to add those 2 rows together, and it's going to give me my bottom row, which is going to be labeled total mix. Okay? Now, just a minute ago, I said sometimes if you want a different shade of red, you may add white to red to make it lighter. Mix 1 might be the red paint. Mix 2 might be the white paint. Over here would be how much of each we're going to put in. Okay? And of course, you mix it all together, and then here you're going to have your totals. Okay? Now, let's look at our first example. Okay? And let's see how this table is going to help us organize our information and set up an equation. All right, so if I look at the first example, peanuts worth $2.90 per pound were mixed with cashews worth $4.60 per pound. to produce a mix that is worth $3.50 per pound. How many pounds of each were used to make 51 pounds of the mixture? Now, I want you to think about this. You've gone to the store and seen cans of mixed nuts. Okay, it has all the different types of nuts in it. Okay, now we know something. The peanuts are definitely going to be the cheapest. Cashews are going to cost us a lot more. And we want a mixture that's going to cost me somewhere in between. And I also know that I'm going to have 51 pounds of this mixture. Okay. So how many pounds of peanuts will I really have? How many pounds of cashews will I need? That's that question. Okay. So let's start organizing our information. Let's make our 3x3 table. I notice I'm not being like crazy with the ruler, making everything perfectly straight. And I am going to use for my column headings, M sub 1, M sub 2, mix 1, first mix, mix number 2, and then this is going to be total mix. So I love to abbreviate, okay? So I'm going to abbreviate. Now up here is the amount. We said this was our percentage, and then we said over here is going to be our total. And I'm going to put TA for total amount. Okay, we said on the rows we're adding, on the columns we're multiplying. Okay, now I've got my table set up. This table is not going to change from problem to problem. Okay, now I need to start putting in the numbers that I see in my problem. Okay, now I do see 4 numbers. Okay, right here it says peanuts worth $2.90. Okay, now I'm going to go right here for just a second. And I'm going to let me grab another color. I'm going to let mix 1 be my peanuts. I'm going to let mix 2 be my cashews. Okay, just like that everything's there. Okay? Yeah, so I'm just saying the first thing I'm mixing together is the peanuts. The second thing that I'm mixing together is going to be the cashews. Okay? Now, let's talk about this percentage. Sometimes the percentage is actually going to appear as a dollar amount, okay? Sometimes that percentage is going to be a dollar amount, okay? So if it tells me that peanuts is worth $2.90, I'm going to put $2.90 right there for peanuts, okay? Now, it says it's mixed with cashews. We said cashews is our second thing we're mixing together, so that's our middle row right here. And it's worth $4.60. So where are we going to put that number in our table? We're going to put it right here. Okay? Now, let's keep going. It says they're going to be mixed together to produce a mixture worth $3.50 per pound. That $3.50 is what you're going to get when you mix all the peanuts and the cashews together. So I'm going to take this $3.50 right here, and I'm going to put it right here for my total, just like that. Okay? Now, I have one more number in here. Okay, in this last sentence, how many pounds of each were used to make 51 pounds of mixture? 51 pounds of mixture. That's what you're going to have at the end after you got this big old bowl full of peanuts and cashews. If you take it up to the scale and you weigh it, it's going to total up to 51 pounds. So I'm going to put the 51 pounds right under my amount because that's how much I'm going to have in the end. I'm going to have a big old pile of peanuts and cashews that weigh 51 pounds. Okay? Now, let's back this up because we got some more spaces to fill in. I need an X. I need an X because I need to solve an equation. Okay? Now, here's what we're going to do. We're going to make the peanuts, or our first mixture, our X. Okay? I could do either, but I'm going to make the first one X. Now, wait. Look right here. What am I going to put for mix 2? Well, if this is X for the amount of peanuts, and my total amount is 51 pounds, I know that the pounds of cashews that I'm going to use is going to be that total of 51 minus those peanuts. Okay, the cashews is going to be the total 51 pounds minus how many pounds of peanuts I'm going to use. So right here, I'm going to put 51 minus X. Okay, now stop the video if you need to, reverse it, listen to that explanation again. If you're going, huh, do what? Then keep going. Okay, if you got it, keep going. Now, remember we said up here, we're going to multiply going across our rows. So that is exactly what I'm going to do right here. So I'm going to have 2.9x. I just dropped that 0 off because I didn't need it. I'm running out of room. Okay, now let's grab our calculator and let's multiply right here. Now remember, this is similar to the distributive property. So if I multiply 51 times 4.6, oh, I'm going to have to write small. I'm going to have 234.6 minus, oh, I ran out of room, 0.6x. That's a 6 right there. Okay? Next time I remember to make my table bigger. Now, let's multiply across the bottom. 51 times 350 comes up to be 178.5. Okay? Now, I've got the information to make my equation. My equation is actually going to come from right here. It's going to come from right there. My total amount for peanuts plus my total amount of cashews is going to eat the total mixture all put together. Okay, now think about that. Over here we were looking at how many pounds of each. Here we were looking at the cost of it. Here we're looking at the total cost and amounts. Okay, so I'm going to add this column together, and that's where I'm going to get my equation from. Okay, so let's do that right here beside it. So I'm going to do 2.9x plus, right here, I'm going to have 234.6 minus 4.6x. And that is all going to equal up to the 178.5. Okay, now right here I have just got myself a good 3-step equation I need to solve, so we can do that real easy. You can grab your calculator. Let's combine our 2.9 and our minus 4.6, and that's going to tell me negative 1.7x plus this 234.6 equal to 178.5. Okay? Now, let's go ahead and do our last 2 steps. So let's subtract the 234. So what I'm going to have is negative 1.7x equal to 178 minus 234.6 is going to give me negative 56.1. If I do the division here in the last step, I'm going to get x equal to 33. Now, what does that mean for me? Well, this is what it's going to mean. I'm going to have 33 pounds. Look over here where my finger's bopping up and down. 33 pounds of peanuts. So 33 pounds of peanuts. Now notice I use my unit of measurement. Now, how many pounds of cashews? Well, the pounds of cashews, I can just scribble right here, is 51 minus 33, which is 18. So down here you can see that all I did was just subtract them. 51 total minus 33. That's going to give me 18 pounds of cashews. Have I answered the question that they asked? Absolutely, because it said how many pounds of each. And I have pounds of peanuts and I have pounds of cashews. Okay, stop your video right here, copy it down, back it up, reverse it, rewatch it if you need to. Okay, then go to example 2. Okay. Now, example 2 is a little different, but it's still the same problem solving. So let's copy down number 2. A 2% solution of acid was mixed with a 12% solution of acid to make an 8% solution. How much of 2% and 12% solution were used to make 10 liters of 8% solution? So this is like having a cup of coffee that is way too strong, and you kind of pour in some really weak coffee that's not strong enough, just to get that kind of blend in the middle. That's perfect, okay? I'm still going to use the same table, so I'm going to write that in. This time I'm actually going to make sure I make all my columns wide enough, hopefully. Okay. Now, we're going to have amount, percent, total amount. We're going to have mix 1, mix 2, plus to make total mix. Okay. Now, I'm going to go back to my problem right here. It says I have a 2% solution of acid. Okay. It's mixed with a 12% acid. So the two types of acid they're talking about is 2% and 12%. Okay, can y'all see that? And I need to make an 8% solution, don't I? So the total is going to be 8%. Okay? Now, I'm going to use these percentages in my column right here. But now you remember, those 2%, 12%, 8%, you can't use percents. You got to change them to decimal equivalents. So 2% is 0.02. 12% is 0.12, and 8% is 0.08, okay? So I have just used my 2%, my 12%, and my 8%. Now, let's take a look. The last sentence, how much of 2% and 12% solutions were used to make 10 liters? You know that L's liters, 10 liters of 8% solution. So that means my total amount is going to be 10. Now I'm going to pull that same variable trick I did on the other one. Let's let X mix 1 or that 2% be an X amount. That's X number of liters. Well, what would be the amount for my second mixture or the 12%? That would have to be 10 minus X. Okay? Now, let's do our total amount. Well, how did we do that? We said we're going to do what? We're going to multiply. So, for 2% solution is 0.02X. Now, for my 12% solution, I'm going to do the distributive property right here. So I'm going to have 1.2 minus 0.12x. And I swore I was going to make that box big enough, and I didn't quite. Okay? Now, right here at the bottom, 10 times 0.8. Well, 10 times 0.0, I'm sorry, 10 times 0.08 is 0.8. My mouth got ahead of my brain. Okay? Now, can I set my equation up? Do we remember where we got that from? We got it from right here. Adding our total 2%, the total of our 12% to get the grand total for that's 8%. Okay? So for my equation right here, I'm going to have 0.02x plus 1.2 minus 0.12x equal to 0.8. Now, let's combine our like terms. So I'm going to do 0.02x minus 0.12x, and I come up with negative 0.1x plus 1.2 equal to 0.8. If I subtract the 1.2 from both sides, that's going to give me what? Let's see, that's going to give me negative 0.1x equal to negative 0.4. When I divide that, I'm going to get x equal to 4. Okay? Now, let's talk about that. What does that mean? What is x? X was how many liters of 2% solution I have. So I would come right here and say, okay, so I'm going to have 4 liters of 2%, and I'm just going to abbreviate solution. Okay? Well, if I have 4 liters of the 2% solution, and I'm making a total of 10, how much on the 12% do I have? Well, I have 10 minus 4, which it would be what? 6 liters, right? And I circle that, just like that. Now, again, pause your video right here, get this recorded down, and then we'll move on to example 3. Okay, so now let's look at example 3, okay? Pure copper was mixed with a 12% copper alloy to produce an alloy that is 32% copper. How much of the pure copper and how much of the 12% alloy was used to produce 44 kilograms of 32% alloy? Okay, so let's just clarify a couple of words here, science words. If they say pure, what they're referring to is 100%. It's not mixed with anything. That is nothing but a pile of copper. Okay? Now, notice they're going to mix that 100% pile of copper with a 12% copper alloy. The word alloy just means that it is not pure, that it is mixed in with something else. And that's generally how a lot of metals are when they come to you. Even if you're wearing a gold ring, your ring is not 24 karat gold. It's always usually mixed in with something else to make it harder or make it cheaper to produce. Okay? So alloy just means you have that metal mixed in with something else to make it cheaper, typically. Okay? Now, let's go ahead though and let's set up our 3x3 table. Now, we have mix 1, mix 2. We're adding them together to make total mix. We have our amount here. We have our percentage, and then we have our total amount. And remember, while we're adding the rows, we're multiplying the columns. Okay? Now, let's go back to mix 1. Mix 1 is this 100% pure copper. Okay? So my pure right here, what I'm going to put here is that 100% or the pure. Okay? Now, what decimal value is equivalent to 100%? 1. Okay? Now we're going to mix that right here with the 12% copper. So here's our 12% mix. We know the decimal number for 12% is 0.12, okay? And we want to produce an alloy that is 32%. So our total mix is going to be 32% or 0.32. Now, one little piece of information. How much of pure copper and how much of 12% alloy were used to produce 44 kilograms of 32% alloy? So our total amount here is 44, okay? Now we remembered before, we're just gonna let the first mix be our X, okay? Now, how do we get the second mix? We subtract the first from our total. So we're going to have 44 minus X right there. Now, all we got to do now to find our third column is, let's just multiply. Well, X times 1 is just X. Oh, that's so easy. Now, when I multiply my 12% right here, I'm going to have 12% times 44, which is 5.28, minus 12% times X is 0.2X. Okay, now let's do our last one right here. We're going to do 44 times 0.32, and that's going to give me 14.08. Now, we've also discussed that our equation comes from using our total. And I didn't show it very well. Let's use a darker color to emphasize that. So we're going to use this column, adding it to get our equation. So what I'm going to have, let's get right here to the side, I'm going to have X plus 5.28 minus 0.12x equal to that 14.08. And here's our three-step problem. Combine our like terms, we get 0.88x plus 5.28 equal to 14.08. Now, I'm not slowing down with the calculator here. You can do it with the calculator, you can do it without a calculator. Watch your decimal places, okay? Now, subtracting 5.28 from both sides, it's going to come up to 0.88x equal to 8.8. A lot of 8s floating around there. Now, if I divide 8.8 by 0.88, I'm going to get x equal to 10. So what is that telling me? That is telling me that I need 10 kilograms of pure copper. Well, if I need 10 kilograms of pure copper, how much of that 12% copper am I going to need? Well, that's going to be 44 minus 10, and we can all do that in our head. That's really easy. That's 34 kilograms of 12% copper. Now, finish copying these notes. Make sure you get them into your interactive notebook, and then you can go to Canvas and find the mixture word problem assignment.